here's an example of toluene disordered across a symmetry element. Once again, we're getting the file by clicking on the link here, and that downloads the zip file. And if I head over to my download area, I should have the file. There we are. And I am going to copy this file, Control-C, into a folder I made previously, which is called just the name of the structure, because that way we can keep things quite tidy. Okay, we open OLX2, go back to here, and I am dragging the file in here. So this is a combined embedded zip file that has got the HKL and the res file in it, and we can tell that because if you go to work, we can go down here and we can see these options and we can extract and open. So currently this is green, that means it's a zip file, and I'm extracting this and open it. It's now turned blue, and that means we are in the res file, and this is a structure we can actually work with. And if we refine this, we should get exactly the same structure that was deposited in the ZIF. Okay, so let's fix the lines. I only want 4 lines here because we want to concentrate on this, and it's this toluene that we are going to concentrate on, and to do that we delete it. We go Control-R to refine, and we don't see anything, and that's because the Q peaks are off. So I'm going to switch the Q peaks on, and this looks, does look like a toluene. That's because it needs to be grown, and if you do that, it starts looking a bit like a toluene. And now there are really 2 ways of modeling this. One of them is using the fragment DB, and that's the easiest way. We just buy a toluene. We go toluene, hit return, and that's the toluene. And you can sort of see it belongs here, and it's going to be in part -1 because it's disordered across the symmetry element, and the occupancy we want to fix to 0.5. Once we've done that, we just go and fit it. So that puts the toluene in the viewer. We select the first atom and then we match it to a peak where we think it's sensible, and then we select the second atom and match it to this one. And I think that's all we need to do. There is no more because these are already here. We can maybe turn this around a little bit, this and this. Okay. Once we're done, we click escape at the bottom, and that's it. It's placed the toluene in OLX2. We hit Control-R and it has grown it now, and hide those Q peaks, and this is quite well behaved. So if you go fuse again, that gets back to the asymmetric unit, refine it, it behaves quite well. We can probably make this anisotropic, and let's add some hydrogens to it, H-add, Control-R, and here we go. So when we grow this, and the way to grow this is to right click on this and go bang, bond angles, and then you see some short ones here, and that makes the equivalent here. And you can see this, and obviously these here, they aren't very happy, and that's because they're right on top of each other, and the refinement really doesn't quite know where to go on these ones. So we could put some stronger restraints on there if you wish. In order to make this visually a bit better, we can select one of those, head over to work, draw, and if you have draw plus installed, you can then group these and make them a particular color, and then you get this sort of view that I've got here where you can see the disorder lying in here. I am now trying to achieve the same result by a slightly different technique, which is much less forgiving and can be quite troublesome, but let's try whether we can do this. Control-G to grow these peaks again. And then what we like to do is we like to find out, we like to isolate something that looks like what we want. So we've got these ones here, we name them name C, and the point now is we go part -1 and the magic -C. So this tells OLX2 that we are trying to model these 2 things overlaid. We now need a fuse, and that gets us back to this. The problem here is that sometimes the atoms sort of overlay, so we need to try a fuse 0.1, and this gives us this here. Now if we refine this, we just do 1 cycle, refine 1, just to see whether it's somewhat stable, and it is staying together, and we find another carbon. So we name this carbon. Okay, it's not a very happy ring, but we can just, in fact, we just need this and do an affix 66 for the moment, and that will constrain this to be a regular ring. Just to make sure that everything is in part -1, and the occupancy should be 0.5, so we got part -1 and 10.5. If we refine this, then we get the perfect ring in here, and we go refine, and now we do, I don't know, 6 cycles here, and we can do the same as we did before, harness, add, and refine. So this is a way of manually constructing these. So the affix 66 is not very happy, obviously. So what we do, we double click on all of this and go affix 0. Of course, what's now going to happen, these hydrogens are going to disappear. So we double click, kill $H, that deletes all the hydrogens of the current selection, and then just do add. Sometimes it's worthwhile selecting something first in case you don't want to add hydrogens that you've already dealt with elsewhere in the structure, and now you know you're only adding them to this. So I'm going add on this, and it hasn't actually added them to here because the geometry is now so far distorted that this bond is too short. So OLX2 says, well, this is not right, and it isn't right, it doesn't look right. That's again because these are obviously lying on top of each other. So you can still add it by going add and go 1, 2, what is it we need there? 137. Oops, that's it. add 137. So this will add them even though the geometry is not actually correct for this. So in this case, obviously it's not quite as stable as the other one. We control H, we do a Rigu, let's do a fairly strong Rigu 0.001 or something like this for the moment, just to make sure that this sort of behaves. It doesn't really want to behave. So in this case, let's go back with the affix 66 on this, and we have a regular ring back, and the hydrogens are on there as well. So obviously the I've lost a couple of hydrogens here. Again, they were not added before because the geometry was too bad. Okay, so this is just another way of doing it. So I think it's clear that the fragment DB is probably the way to go because it's got the restraints in. Of course, you could add the restraints here rather than affix 66. But in terms of showing you how you can generate this, I think that's been shown reasonably well. So again, we can explore this, and the short bond here, then that will grow the symmetry equivalent that's across here. Thank you for using OLX2.